Slide 2. Welcome to this lesson on minimal processing of fruits. In this video, we will explore what minimal processing means, why it is important, and how it helps maintain fruit quality and safety. Minimal processing refers to a series of simple handling steps, such as washing, peeling, slicing, and packaging, that transform whole fruits into ready-to-eat products while keeping them as fresh and natural as possible. The goal is to preserve the fruit's original texture, flavor, aroma, and nutritional value, without relying on heavy processing or harsh preservation methods. To maintain freshness and quality, several techniques are used. These include proper washing with clean water, using sanitizing solutions to reduce microbial load, applying anti-browning agents like ascorbic acid, and storing fruits at low temperatures to slow spoilage. Modified atmosphere packaging, or MAP, is also commonly used to extend shelf life by controlling oxygen and carbon dioxide levels around the fruit. Finally, we must consider safety and quality. Because minimally processed fruits are more prone to microbial growth and enzymatic reactions, careful hygiene, temperature control, and proper packaging are essential. When done correctly, minimal processing provides consumers with convenient, safe, and high-quality fresh fruit products.
Slide 3. Welcome to this introduction to food preservation. In this video, we will look at why food preservation is important, how it has evolved, and the modern approach used to maintain the freshness and quality of food, especially fruits. Food preservation plays a crucial role in extending shelf life while protecting the nutritional and sensory qualities of food. The main goals are to prevent microbial spoilage, reduce enzymatic browning, and minimize nutrient loss. Traditionally, societies have relied on methods such as drying, salting, canning, and freezing. These techniques are effective, but they often change the taste, texture, or appearance of the food. Today, consumer preference has shifted toward products that look and taste fresh. This has led to a growing trend toward minimal processing methods that preserve food while keeping its natural characteristics intact. With the rising demand for ready-to-eat, or root, fresh products, the industry now emphasizes mild processing, freshness, and convenience. Maintaining nutritional integrity and attractive appearance is essential. A common example is pre-cut fruits sold in supermarkets. These products combine basic steps like washing, peeling, and cutting with gentle preservation techniques that extend shelf life, reduce post-harvest losses, and minimize waste. Such minimally processed foods are widely used in fruit salads, juices, and ready-cut fruit packs. Slide 4. In this section, we will explore the concept of minimal processing, an approach widely used in the modern food industry to provide consumers with fresh, convenient, and safe fruit products. Minimal processing refers to a series of simple handling steps that keep fruits as close as possible to their natural state, while still extending their shelf life. The core idea is to use techniques that maintain freshness and reduce quality deterioration. These techniques include gentle operations such as washing, peeling, slicing, and packaging, combined with mild preservation strategies. Unlike traditional food preservation, minimal processing does not rely on heat treatments or chemical preservatives. Instead, it focuses on protecting the fruit's natural sensory qualities such as color, aroma, texture, and nutritional value by using non-thermal and carefully controlled methods. One major benefit of minimal processing is the reduction of post-harvest losses and food waste. Fruits that might spoil quickly in their whole form can last longer once they are cleaned, cut, and kept under controlled conditions. This is why minimally processed fruits are commonly found in products like fruit salads, fresh juices, smoothie blends, and ready-cut fruit packs sold in supermarkets. A key requirement of minimal processing is strict cold chain maintenance. Fresh-cut fruits must be stored between 0 and 5 degrees Celsius to slow down microbial growth and enzymatic reactions. This low-temperature environment helps preserve quality and ensures safety throughout transportation, storage, and retail display. Another essential element is proper sanitation. Because cutting and peeling expose inner tissues, the fruit surface becomes more vulnerable to contamination. Therefore, hygiene practices, clean equipment, and strict temperature control are critical at every stage of processing. When all these elements are applied correctly, minimal processing offers consumers fresh, nutritious processing and how each step helps maintain the quality, safety, and freshness of fruits. Minimal processing involves gentle, carefully controlled operations designed to keep fruits as natural as possible while extending their shelf life. The first step is washing, which removes dirt, microbes, and pesticide residues. Clean water or sanitized water is used to ensure that the fruit surface is free from contamination before any further handling. This is followed by peeling, done either manually or mechanically. Peeling removes the outer layer and prepares the fruit for cutting, although it must be done under hygienic conditions to prevent contamination. Next is cutting or slicing. Cutting increases convenience for consumers but also exposes the internal tissues to oxygen. This can lead to browning and rapid quality loss. To reduce these effects, processors use anti-browning agents such as ascorbic acid or citric acid. These natural compounds slow oxidation and help maintain the fruit's natural color. Another important technique is chlorinated or ozone rinsing, which reduces microbial load on the fruit surface. These sanitizing agents help prevent the growth of spoilage organisms and enhance safety. To further manage freshness, modified atmosphere packaging, or MAP, is used. MAP controls the levels of oxygen and carbon dioxide around the fruit, slowing respiration and extending shelf life. Cold storage is another critical component. Storing minimally processed fruits at 0 to 5 degrees Celsius slows microbial growth and enzymatic activity. Maintaining a relative humidity of 85 to 95% prevents dehydration and keeps the fruit crisp and fresh. Finally, avoiding temperature fluctuations is essential. Sudden changes in temperature can cause condensation, microbial growth, and faster spoilage. Together, these techniques allow minimal processing to deliver fresh, safe, and high-quality fruit products. Okay, next is the slide 6. In this section, we will explore how minimal processing affects the nutrient content and overall quality of fresh fruits. Although minimal processing is designed to keep fruits as close to their natural state as possible, it still introduces certain challenges particularly related to nutrient loss, color changes, and texture stability. One of the most important nutrients affected is vitamin C, which is highly sensitive to oxidation. When fruits are cut or peeled, the exposed tissues come into direct contact with oxygen, leading to rapid degradation of vitamin C and other antioxidants such as polyphenols. However, with proper packaging and the use of cold temperatures, these losses can be significantly reduced. Proper packaging plays a major role in protecting nutrients. Techniques such as modified atmosphere packaging, MAP, help control oxygen levels, reduce oxidation, and slow down enzymatic reactions. This helps retain the fruit's natural flavor, aroma, and nutritional value. Texture is another key quality attribute. Minimally processed fruits maintain their crispness when rapid cooling is applied immediately after cutting. Minimizing physical damage during handling also helps preserve firmness and reduce moisture loss. Color quality is closely linked to antioxidant activity. Using natural anti-browning agents, such as ascorbic acid, helps prevent discoloration and maintains appealing visual quality. This is important because consumers often judge freshness by appearance. Flavor quality is preserved by minimizing enzymatic reactions and maintaining low temperature storage. Cold conditions slow down flavor deterioration and prevent the development of off odors. Finally, shelf life for minimally processed fruits typically ranges from 5 to 10 days under optimal conditions, namely cold temperatures, controlled humidity, and the use of appropriate packaging. When all these factors are carefully managed, minimal processing successfully delivers nutritious, attractive, and high-quality fruit products that meet modern consumer expectations. Okay, next, slide 7. In this section, we will focus on the safety and microbial aspects of minimally processed fruits. Because minimal processing does not involve heat treatment, the microbial risk is significantly higher compared to conventional preservation methods. This means that any contamination present on the fruit surface or introduced during handling can persist and potentially grow during storage. Some of the most common pathogens associated with fresh-cut fruits include Escherichia coli, Listeria monocytogenes, and Salmonella. These microorganisms can cause serious foodborne illnesses, especially when fruits are consumed without further cooking. Therefore, ensuring proper hygiene throughout the entire processing chain is absolutely critical. The cutting and packaging stages are particularly sensitive because the exposed fruit tissues provide nutrients and moisture that support microbial growth. To reduce microbial load, processors use sanitizing solutions, commonly containing 50 to 200 ppm of chlorine, or alternative sanitizers such as ozone or peracetic acid. These sanitizing steps help in lowering the initial contamination level but must be used correctly to be effective. Another essential element is cold chain management. Minimally processed fruits must be kept at consistent low temperatures from processing to storage, transportation, and retail display. Temperature abuse even for short periods can lead to rapid microbial growth and spoilage. Food safety systems such as HACCP, or Hazard Analysis and Critical Control Points, provide structured monitoring tools to identify, control, and verify safety risks at each stage of production. Regular monitoring helps ensure that hazards are effectively managed. Finally, consumer education plays an important role. Consumers must understand the importance of refrigeration and quick consumption once the package is opened. Proper storage at home helps maintain safety and prevents contamination. When all these safety practices are followed, minimally processed fruits remain fresh, nutritious, and safe to eat. Okay, next is the slide 8. In this section, we will look at several case studies and real-world examples of how different fruits respond to minimal processing. Each type of fruit has unique characteristics that influence its shelf life, quality, and the type of handling methods required to maintain freshness. Understanding these differences is crucial for anyone involved in the production of ready-to-eat, or root, fruit products. Let's begin with pineapple and papaya. Both fruits contain high sugar content, which makes them naturally sweet and desirable to consumers. However, this also means they spoil more easily. High sugar levels promote rapid microbial growth once the fruit is cut. For this reason, immediate cooling, clean handling, and proper packaging are essential. Pineapple and papaya are commonly used in fruit mixes, but their short shelf life means processors must maintain strict temperature control from cutting to consumption. Next, we have guava, a fruit that browns very easily once exposed to air. The browning is caused by enzymatic oxidation of polyphenols, which leads to unattractive discoloration. Because appearance is one of the most important quality attributes for consumers, guava requires an antioxidant dip, usually ascorbic acid or citric acid, immediately after cutting. This helps maintain its natural color and extends its marketability. In Malaysia, guava is often sold as fresh-cut sticks, so minimizing browning is essential for commercial success. Moving on to mango and watermelon. These fruits are particularly well suited for fruit cups due to their pleasant texture, vibrant color, and consumer acceptance. Mango pieces maintain their softness without becoming mushy when stored properly, while watermelon provides refreshment and volume. Both fruits, however, are highly perishable and require strong cold chain maintenance to prevent texture loss and microbial spoilage. Finally, let's look at a broader case study from Malaysia's root fruit industry. Many Malaysian companies now use vacuum packaging combined with cold chain delivery to maintain quality during transportation. Vacuum packaging reduces oxygen exposure, slows oxidation, and helps preserve both flavor and color. Cold chain delivery ensures that minimally processed fruits remain at safe temperatures from factory to retail outlets. These case studies highlight that each fruit has distinct challenges, but with the right techniques such as antioxidant dips, vacuum packaging, and strict temperature control, minimal processing can successfully deliver high-quality, convenient root fruit products to consumers.